Did you guys get it to run?
I have a really weird graph.
Yeah. Oh, well, it's actually still running still. So the reason that mine created this error is because the type of data that it's reading the date in right now is factor instead of as a date or as a numeric. So
You're doing this to KP checks instead of to daily max.
you're right. Thank you. That would be probably the
It's not making a difference.
yes. Thank you for catching that. So let's see if we don't need the as done numeric. Okay.
Maybe to capitalize the whole word on a date, D-A-T. The daily max.
That's true. Thank you, Tina. So, there we go. Yay! So, these are the types of things you constantly have to watch out for, is how you name things. So like, the column name is date capitalized versus date lowercase. So it's easy to miss those things, and why it's helpful that when you're having issues, ask someone else just to look at your code really quickly and say, am I missing like a stupid error where it's I miswrote date? So now, if we plot it, it did it super quickly. And there's a lot of dates here, obviously. But you see that the dating is correct now. Does that make sense to you guys? No? Yes? Did it work for you guys when you change date to be capitalized instead of the way that I had it?
Would you show the full script?
Yep. Did you guys get that to work? Yes.
I got lost in the Instagram because of my cleaning. My cleaning of the table didn't work, so I'm just observing what you're doing.
Okay.
And I'm gonna do it
Okay.
from scratch.
Okay, and I will send out the code so that you guys will have this. Because I have a clean one that I did beforehand that ran just fine. But I wanted to actually type it with you guys so you guys can see the common errors that happen when you just are working in it. So I have a clean one that I will send to you guys that also has some notations in it so you guys will be able to see that as well.
So I'm just observing what you're
Yeah,
doing.
that's fine. Yeah.
For the daily.ix line, or with the $sign D.
Yeah.
At the end of that line where you have percentage day, percentage month, percentage year, why? Why do you have that like that?
So what this is saying is we want to read this column as a date in this format, which is day \month \year.
Okay.
And the capital Y should be to read it as a 4-digit year instead of a 2-digit year.
Okay.
That should be what it is.
These are the errors.
You can actually Google like what those different types of formatting are. And that's probably one of the biggest things that I found is just Googling if you have an error. Just Google what the error is or Google the function or what you're trying to do. And someone else has done that before. Yeah, or you just okay, so did we all get there? You one more here, so problem? Okay. What I'm going to do next still has to do with the plotting. So I'll just move forward kind of briefly. We have a whole bunch of dots, so it's really confusing. And it's also kind of boring. So what we can do is we can add some more information to this plot function. So if you highlight it and then paste it down below in the script, you can keep that old one, but then also begin to make some edits to this. So the first edit is we're going to change the color of the points to be orange. So within the plot function, COL equals and then open quotation marks and a color tells it to recolor all of these points to whatever color we're calling. And you can Google online to find specific, like what the specific names for them are, but there are literally hundreds of different colors that you can use in R. So we use orange there. We also want to actually change from points to make a line graph. So if we do type equals L, we're telling it to create a line instead of all these different data points. So we're connecting them together. Does that make sense?
We have date in x-axis
Okay.
and
And you can even change the color of your labels and your title as well. So just to give you guys another idea of like some of the other versatility of this, we'll call those navy.
So navy is a color?
Navy is a color in R. And so it creates,
I think you're missing a bracket here.
yeah, so it creates that, like this, right there we go.
Oh, no, it's there.
It changes the color of your points, and also convert to lines, and then also change the color of your labels.
Oh, I
Yes.
just wanted to ask, does it matter which order
I don't know
that you,
what- I don't know what
the
this
color,
error
does the color have to go after the,
Once you get past the X and the Y, everything else can kind of be mixed together. I typically try and put the color of your data before I start putting in labels for things. But yeah, everything else can be rearranged for the most part.
okay.
I just don't know what it is based on the plot. It's something with the plots that I
Yeah.
use.
It was flooding before,
Uh-huh.
right? I was showing it to you, but I added this code,
Uh-huh.
and then I tried to rerun it again, so it's showing that.
Here.
working like before I
Right.
added that one.
Yeah. Okay, so let's plot
So we're plotting this now.
correct. Yeah.
As D.
I feel like it's just so goofy that
Yeah.
Plot, then space, like equal.
There we go.
It's one.
So something
something.
messed up. So I just went back to reading it back in. There we
L,
go.
thank you.
Yep.
L.
So yeah, there's a lot of functionality within plot to create different types of plots. So you can change the colors of things, you can change it from points to lines. There's a variety of different options with that. And you can just Google or do question mark plot within the console and you can get more information about those. So that's exciting and all, but that's just a plot. That isn't actually like analyzing anything. Let me quickly switch back to the PowerPoint, catch us up on that one, just to make sure that I'm not forgetting anything. So yeah, you can do data exportation in the statistics analysis. So I'm about to do are the basic statistics. The 3 M's like mean, median, mode. We did histograms. We'll do a simple linear regression, hopefully. And also we'll talk about how to export your data so that it's not just sitting in R, but you can export it and be able to use it elsewhere.
It's as easy as changing this Y
So,
to uppercase Y.
plot is, as we've just used, it's the basic R function, but there are other plotting packages. So ggplot is one of them, and there's a bunch of other ones, and they all, some of them have a little bit more flexibility and look fancier than plot, but it just requires going in and taking a look at what the function is set up to do within those. So that's easy to Google and check out within the help section of our studio. So yeah, this was that hourly data that we were cleaning. I went ahead and plotted it for us as well, so you can see, you can even do it with this too. So basic statistics, mean, median, max, min, we already did the histogram, and then we can do the linear regression as well. So let me go back to our studio and move down to this line. Okay, so let's do, we'll just test and see what is the maximum daily temperature in Phoenix of all time. So max is, again, ours is a statistics program, so it's built on basic stats. So max, open parentheses, close parentheses, and within that, you just tell it what is the vector of the column of information you want to find the max of. Run that function, and it tells us NA. So that is due to how it is designed, the type of data that it is. So you can find out what the type of data any column, any data table is by doing class. And so it tells us it's numeric. So there should be, within that, you should be able to spit that out.
I think it's because there's NAs probably.
Probably,
Makes sense.
yeah.
So if you omit NAs.
Yeah.
Yeah, so. So you can give it equals true.
I think
that's right.
dot omit with the daily max min.
Well, we can try.
Did you change the color? No?
There we go. That worked. Yeah. So there's a lot of like simple functions within R. Okay. So it gave us the daily value of 50. Now this is in Celsius, so that's why it's ridiculously low. But you're telling me to find the maximum of non-NAs within this column. And so it plots out with 50. In the code that I'll give you, there's a way of aggregating data from the hourly stuff that we were cleaning to actually create daily max mins from that other set of data. So min would work the same way. Min, NA, omit, daily, max min, and we'll do it of the minimum temperature in Phoenix, negative 8.3 Celsius. So pretty cold. So that's how you do max and min. Median is median, and should just work this way. So let's do that. Nope, do the NAs again. So there we go. Median, and then mean is the average. So mean, median. You could also do mode if you wanted. NA, omit, daily, max, min, $, minimum. We'll do max because it should be close to the median. So 30.6 and before it was 30.7, so they're similar. Mode without the yeah, there's the mean. Mode should be something. It could really be anything. I want to see. I have not looked to see. Okay, max min of Tmax. So this would be the most common number in the data. Oh, sorry. Mode is also like a class function.
There's not a function for mode in
Yeah.
the base.
So yeah, mode is giving us that class again. Okay. So beyond just the basic stuff, what about like linear regression?
Well, before, where do you locate? So you found the minimum and maximum, but where do you locate exactly in your
What am I
time?
looking?
Like the minimum, it was minus 8.7 and maximum 30.
Mhm.
But where can you locate like when that specific point you're looking for? Does it show or just tell you the?
You can plot it. Would be one way. Another way is you would say, I want you to give me daily max min
Year or yeah.
where daily max min of $, oh sorry, should have, so this would be the date, the daily max min there we go.
90.
The-
20 of July of 19.
Mhm.
Oh,
Yeah.
I could-
Yeah, so that's how you would pull that information out from a different spot. So what we're saying is, what is the maximum daily temperature and what is the date associated with that? Does that make sense what we're doing there? Okay. So then it pops that out for you there.
90.
Yeah. So that's just what it happened to be in this instance. So looking forward into more of the statistics then, linear regression is probably the most simplistic of ways of analyzing data in terms of, if it's a relatively normal set of data, then linear regressions probably give us some idea of how the data is changing over a different variable. So in R, linear regression is using the LM function. So we're going to create a linear model called Phoenix warming daytime .lm. Because we assume that over time, increasing urbanization, climate change, global warming, all of that, Phoenix should be warming over the past 80 years. So we're going to create this object, and we're going to tell it that it gets an LM, which is the linear model function. And in it, what we're creating a linear model of is the daily max min, maximum temperature as a function of daily, max, min, date. So within this, we're telling it that we want to see how does the maximum temperature change as you change your time. Does that make sense, what we're doing there? Okay. You could flip the two around, but it would give you the transpose slope, which would be really confusing. So do that, and it should spit it out pretty quickly. You can see what it gives you, what all the information is that's stored within it by going to your console and just typing that linear model back in. So this gives you a lot of information that you can then pull from. So it gives you what the formula is. It gives you, yeah. Summary, ANOVA can also be done on this. So this just gives you the basic, what's the intercept and what is the slope. So if you go in, let me scroll back down here and do summary, Phoenix warming. So here you can get your standard error, you can get your t-values, significant code, F statistics, R squareds. All that can come from summary whenever you do a linear model. So all that data is automatically created when you run the LM function. You don't have to calculate these things on your own. You can also run an ANOVA, create an ANOVA table of that. It's just ANOVA of Phoenix. And so that gives you an analysis of the variance table. So it gives you degrees of freedom, the sum squared, the mean squared, F value, residuals, etc. So again, R was made for basic stats. So it's really simplistic to be able to get these types of things to work. It's nice to know what the linear regression is, but it's even better if you can see what it does relative over time. So how do we plot it against all of the data? So I'm going to copy the previous plot that I made, bring it down here, paste it, and then to add a linear regression to it, you use AB line, and then you tell it what the line is. It's this linear model, and then I'm going to tell it to be a different color so that it stands out versus the orange. Now, one thing when you are adding a line of code after plot, you need to make sure that you run them together. You can't just run plot and then type in AB line, do all this, and hit AB line. What it will do, let me show you. If you run just the plot, it'll do it, fantastic. And then you come down to AB line. There we go, it actually did work. So you can now see the line through the plot. So here's our linear regression. Doesn't look like much. But that's because we're using afternoon maximum temperature. In Phoenix, we've actually seen the minimum temperature change the most. So you guys don't have to do this, I'm just going to do it to show you the difference. So night, linear model, daily max min of T min is a function of date. Alright, so we want to look at the minimum temperature this time and change the name because we don't want to make mistakes on our label. So I ran that, ran this. So there's minimum temperature down there, and there's the line, and it's a lot more obvious. Fancy.
Climate change.
All right, so that's most of what we're going to do in terms of statistics. There's a lot more that we can do. Let me show you just a few of those things through images. So this is mean, median, and mode again. So we just plotted it. Here's the histogram. There's our minimum temperature change. Fantastic. Or terrible, depending on how you want to look at it. So this is from that hourly data that I looked at. And this is your minimum temperature linear model, your median, and your maximum all plotted on the same hourly data. So you are able to plot multiple lines as long as you set up your codes right for it. But beyond that, it's great that we have that, but we have to be able to share that and be able to put it in our papers and inform others about it. So how we can export tables, graphs, as well as even our text. So getting back to our markdown. With tables, we read the CSV files in using read.csv. We can then export that data by using write.csv. And I'll show you guys how to do that in just a second. Graphs, we can do a variety of different images. So you can use, aside from just like clipping the data, using your alt print screen and cropping, you can print it within the code as a PNG, a BMP, a JPEG, a TIFF. You can do that all from within R. And then your text, you can make it look pretty, basically. That was not showing that here. So this is this workshop printed out in our markdown. So it allows me to give you the comments, it gives you the responses, so I can scroll further down so you can see code, you can see graphs. Some of these didn't work out right. Depending on how you set things up, you can create headers, you can increase the font size. All of this is possible in the R markdown. So then your data are inset within text, basically. So that's just one way, that's the way of exporting your text. To export your tables, like I said, you do write.csv. So this is to create a CSV file from what you already have. So you can do Phoenix. So again, we're going back to that data that we cleaned, and you're going to say file name is equal to, and then you tell it where you want it to store it and what you want to call it. So we'll say this, I'll just say this in the test .csv. And so right here you can see where I'm going to be directing it to, because this is where the working directory is. So it's going to, in the folder kphx _ Phoenix, it's going to create a test comma delimited file. And did you hear?
I don't think you have to write file.
Yeah, I think it's just as common.
Oh, is it? So if you do that. Okay, there we go, it's working. I've always used the file name,
Maybe it's like,
maybe.
I've never used it.
So yeah, so then if I go over, or I'll just, so if I go into, so I have this in presentations, the R workshop. Data, a bunch of other files. Here's that test. So then you can open it up in Excel. And select data to see. No, I'm just saying, here it is exported. So that your professors who all use Excel,
Yeah.
they can read it. So that exported it that way. To export images, here I'll just do it for the linear model. You want to do it as a PNG file. You open it there, and this might be where I was going to file names from. Sure I can- File name, and then we'll call it daily min.png. And then within this, you can determine like the pixel size that you want. So we'll do so width and height are giving it the X and Y pixel sizes that you want. So just to kind of give you guys an idea of that. And then now that you have this line of code, you can then
Quotations.
oh yeah, thank you. So now the next time I plot anything, it'll go into this file name as a PNG. So I can plot that. And down here you can see it has plotted out a PNG file that I can open up.
I think you have the
And apparently I won't try it.
Yeah, dev.office.
That should only,
It still has the graphics of it.
okay. Yeah, so then dev.off means you close off that function. Now let's see. There we go. Oh, it opened up twice. So that's how you can print to PNG, or JPEG I think is just JPEG open parentheses instead of PNG. But if you like question mark JPEG or PNG, it'll tell you that. Yeah.
What was that line?
Dev.off. And it basically is, so it works on multiple different types of imaging things. So you can create multi-panel images as well. And that's how you close it off so it doesn't keep replacing that same PNG file over and over and over again. And then, yeah, that is the short of this. There are a lot of other things that we can do beyond this. There's a bunch of fancy stuff that I won't go into, but these are some things I have done in the past and I'm still doing. So you can do quantitative stuff like principal component analysis. You can do jackknifing, bootstrapping. Nonlinear regressions are all possible within R. Qualitatively, you can do chi-square analyses and use qualitative data within R like you would SPSS or SAS. You can even do spatial analysis. You can use shape files like you would in ArcMap. You can use raster data. You can do it to do some mapping. You can do distance measurements. You can do interpolations over spatial variability as well. And then there's also, as I mentioned, FTP access. So you could actually go in, and if all of your data is on an online repository, you can actually download that data through RStudio itself. So here's just a few files. This is from bootstrapping. I created confidence intervals of data with that. This is qualitative data that I then was, this is not actually chi-square analyses, but this is like the precursor to that, setting it up for it. So looking at how housing type varies by income. You can do that within R. You can create maps with different locations across a Google map even. You can use Google Maps, you can use OpenStreetMaps, you can do a variety of different types of mapping with that, including stuff like this, where we interpolated data over a city, Houston. So all these things were done completely in R. And so it's all possible. A lot of it is just Googling what you want to do and Googling the different functions that are out there. So it's a lot of trial and error and Google. That's basically what I do all the time.
Is
So-
there like a dictionary to learn the language? Like you say, C means list. So is there somewhere you can learn like some variables and what they mean?
Yes, the data camp. Do you know about data camp?
I do not know about data.
If you go to datacamp.com, I find it a friendly way to get started. They sort of hold your hand along the way.
Mm-hmm.
And if you go to learn, there's like Introduction to R, they have a bunch of R classes.
So
you
they
can
are like
start-
online courses?
It's all online, and it's always been free for me,
Nice.
so.
Yeah.
I think sometimes they have classes that they wanna charge you for, but like the basic ones are all free. But there's also lots of other things that they vary in level of friendliness, I guess.
Yeah, so
Nice.
when I Google a lot, I end up on this website, rdocumentation.org. You can search any packages or functions, and it'll give you that information that comes in the help tab. So if you look for C, there's a function C. This one is sets contrast attribute for the factor. This one's in the base, so this combines values in a vector or list. So this is the generic function that we were using. So this is how we were using it. C, open parentheses, and then everything we wanted in there. Our documentation basically pulls from the RStudio help page to find those things. And so if there's a problem with how I'm using a function, or I can't remember how to use a function, I will frequently just Google that function, space R, and see what pops up.
Okay.
If you're kind of a follow along learner, like I am too, I got started by watching YouTube videos. People will do series of like intro to R YouTube videos, and you can just type along with them, and that was the easiest way for me to get started.
Yeah.
And then you have like this baseline understanding of how it works, and from there it's a lot easier to jump off and Google stuff.
Yeah.
When you know nothing and you
Okay.
Google something, like
Yeah.
you might still
There's a
know
lot of
nothing.
jargon.
Or
'cause
feel
there's
overwhelmed.
jargon.
Yeah.
Yeah.
Okay.
Yeah.
But the scary but also good thing about R is that it's open source, so it means that whatever problem you've run into, someone else has probably already run into it and has then posted it somewhere and asked questions of people. And sometimes you get great answers, sometimes you get terrible answers. But through doing that, you better understand the function itself and also better understand what you're trying to do in R. So like the last thing I'll show you is how to do FTP stuff. So in the same window where you have console, there's a little window next to it that says terminal. And that is basically your, if you're on a Windows, it's your bash scripting, or it's your command line in Mac. If you do FTP, I'm trying to remember where I got all of these from. I'm gonna go find it real quick.
Do you have like your complete code, like for everything
Yes.
that you'll send out?
Yeah,
to
it
everybody?
is available.
So I can show them how to do all of this, or rerun it.
Yeah. So I created an R markdown for this that has the same information. So there we go. Okay. So open ftp.ncdc.noaa.gov. This is a repository of air temperature data, atmospheric data from across the country. So if you're working and you need air temperature data, you can pull it from here. So it's now asking me to log in. It's fantastic because it's a government website, and with atmospheric data, they have to make it publicly available for free because it's the US government. So the username in this instance is anonymous, and your password is your email address, because they do want to know who actually is using it. Once you do that, anonymous access is granted, and then you can begin, using command line, you can begin to access the data that you might want. So where I got this data from is from this FTP. So now